Hi, today we will study graphs of linear functions. Linear functions, when mapped on a graph, give us straight lines. So we will study the algebra, which is the function, and the geometry, which is a straight line on a graph. The simplest lines we know are the horizontal and vertical lines. Let's take a look at their graphs and deduce something about their equations. So here's a two-dimensional graph, and I mark this horizontal line at, say, y-coordinate of 5. And another one here, and say the y-coordinate of -4. What can I say about every point on this line? So let's look at some coordinates. So this coordinate could be 2, 5, this could be 3, 5, this is probably 6, 5, this is -3, 5, and so on. So every point on the line has something in common, and that is that the y-coordinate is 5. Only the points on this line will have y-coordinate 5. So a nice way to describe this line would be to say y equal to 5. Y equal to 5 completely captures the points on this line and no other points. So it is the equation of the line. It's an equation because it's involving x and y and an equal to sign. And if I were to look for all the points with y-coordinate 5, I would get this straight line. How about this horizontal line, B? Well, here every point, if you were to write their coordinates, would have y-coordinate -4. This would be 2, -4, 6, -4, -2, -4, and so on. So I could capture all the information about this line algebraically by saying y equal to -4. What about the biggest horizontal line there is, the x-axis? What is its equation? Well, it passes through the origin, which is 0, 0, and every point has y-coordinate 0. So the x-axis has equation y equal to 0. In general, every horizontal line will have an equation y equal to some constant. That constant will determine where the horizontal line is placed. How about vertical lines? So let's look at a vertical line. Let's look at this line. So this line has something in common for all its points. The x-coordinate is 3. All the points have their x-coordinate equal to 3. So its equation can be x equal to 3. Since no other point in the graph will have x-coordinate 3 except the points on the line, and every point on the line will have x-coordinate 3. It's a vertical line passing through 3, 0 and all other points with x-coordinate 3. Similarly, this line will have equation x equal to -3 for the same reasons. Every point on the line has x-coordinate -3 and no other point has x-coordinate -3. So the equation of any vertical line can be given by x equal to constant. That constant again determining where this vertical line is placed in our plane. Slope of a line. So everybody knows the concept of a slope. Let's understand this from scratch. So what tells me how a line is behaving or how a line is growing or how a line is inclined? Well, suppose I have a line like this. Suppose I have 2 points on the line. So if I were to start at this point A and if I were to move to this point B, what exactly have I done? Well, I moved a certain horizontal distance and I moved a certain vertical distance. So let's give it coordinates. Say this point was 5, 2, and this point was 8, 6. Then the horizontal distance I moved from A to B is effectively the horizontal distance I moved from A to X, which is 8 minus 5 equal to 3. And the vertical distance I moved from A to B is the same as the vertical distance from X to B, which is 6 minus 2 equal to 4. So to get from A to B, I've moved a horizontal distance of 3 and a vertical distance of 4. How do I use this information to get me a single number which will capture something essential about this line? If I look at two other points on the line, again, I'll be moving some horizontal distance and some vertical distance to get from, say, C to D. Since they're all on the same line, and since this line is a straight line, the amount I move horizontally and the amount I move vertically should be related to each other. And that relation is called the slope. The slope can be defined in many different ways using the horizontal distance and the vertical distance. But people have agreed to use one particular definition and we'll stick to that. And that is vertical distance moved divided by horizontal distance moved. Some people like to call it rise over run. Rise is, of course, the vertical distance you move, and run is the horizontal distance you move. So if I divide the rise by the run, I get a number which pretty much captures how the line is inclined, and we call it the slope. So it captures the inclination of the line. It's obvious to see if I move a greater vertical distance in the same horizontal distance, then I'll get a larger slope. Let's see some examples. So let's look at this line and say this line. So let's look at line A. So I have 2 points, X and Y. So I move a horizontal distance and a vertical distance. Let's call the horizontal distance h1 and the vertical distance v1. So the slope of line A, is v1 over h1. If I were to look at the slope of line B, then look at this as v2 and h2, the horizontal distance and the vertical distance. Then the slope of line B would be v2 over h2. Even visually, we can say that V2 over H2 will be much greater than V1 over H1 because here the V1 is smaller than the H1. You moved more horizontal than vertical, while here you moved more vertical than horizontal. So as the vertical component increases and the horizontal component decreases, as you're taking the ratio of vertical over horizontal, the slope will increase, as it should, because this line B has a greater inclination or a greater slope than line A. How about this line? This line seems interesting. So I take 2 points. Now, to achieve this vertical distance of VC, of V3, let's call it, I need to go a horizontal distance of H3. But I'm moving in this direction. So this horizontal distance will be negative. Let's take 2 points to actually make sense of this. So say this point is minus 2, 2. And this point is minus 5, 4. Then my H3, my horizontal distance, I moved from minus 2 to minus 5. And that's a distance of negative 3. I've gone 3 in the negative direction. And my vertical distance is from 2 to 4. So that's a positive distance of 2. So as I've gone a positive distance of 2 up, I've gone a negative distance of 3 horizontally. And so the slope of this line, let's call it C, slope of C would be 2 over minus 3, which is negative. That's interesting. So negative slopes mean that the line is inclined in this direction. To go up, I have to go in the negative direction horizontally. A line inclined in this direction, however, has a positive slope because to go up from here to here, I'm going in the positive direction horizontally and the positive direction vertically. Say this line. Say to go from this point to this point, I'm going down vertically and positive horizontally. So I'm going negative vertically and positive horizontally. So lines inclined more than 90 degrees to the x-axis have a negative slope, and lines inclined less than 90 degrees to the x-axis have a positive slope. parallel and perpendicular lines. So let's look at two parallel lines. Draw a line here, line here. So what makes lines parallel? Well, obviously they are inclined the same way. If two lines are not inclined the same way, then they won't be parallel. For instance, this line and this line are not inclined the same way. This line A has a smaller inclination than line B, and they end up meeting somewhere. So they're not parallel, they intersect. For lines to be parallel, they have to move in the same direction, so they're inclined the same way. And we know that the slope captures the inclination. So parallel lines should have the same slope. Have equal slopes. We've already captured inclination by the notion of slope. And since inclination of parallel lines are equal, their slopes are equal. What about perpendicular lines? Well, that's a little bit more tricky, so I won't get into it. But essentially, for perpendicular lines, if two lines are perpendicular, then the product of the slopes, say MA into MB, will equal -1. So this is the line B and this is the line A. Then you calculate the slope of A and B independently, and their product is -1. This is an important result. The proof is a bit elaborate, so I won't get into it. How about horizontal and vertical lines? So if I have a line that's horizontal and a line that's vertical and a line that's horizontal. They're certainly perpendicular to each other, but is the product of the slopes -1? Let's see. In the graph shown below, identify the line with the positive slope, negative slope, undefined slope, and zero slope. Okay, let's look at line A. How is it growing? So it's going in this direction. So to go from here to here, I need to go in the positive direction horizontally and the positive direction vertically. So the slope will be the ratio of two positive numbers, so will be positive. So the slope of line A is positive. How about line D? I'm deliberately doing it in a different order. So line D is growing this way. So to go from this point to this point, I need to go in the negative direction vertically and the positive direction horizontally. So the slope will be negative over positive, some negative number over some positive number. So it's negative. We've already seen this earlier. A line inclined less than 90 to the positive x-axis, which is what line A is, does have a positive slope. And line D, which is inclined more than 90 degrees to the positive x-axis, has a negative slope. How about line C? So line C is a vertical line. What is its slope? That's interesting. To move from one point to the other on line C, I move a certain distance vertically, positive or negative, but I don't move any distance horizontally at all. It's a vertical line, so I don't move horizontally at all. So the slope would be some number, say positive, upon 0. If I were to use the formula for slope, because there's no horizontal movement, and this is undefined. You cannot divide by 0. So vertical lines have undefined slopes. People like to say their slope is infinite, but there's no such number as infinite, and slope is a number. So the accurate description is that vertical lines have undefined slopes, or they do not have a slope. How about line B, which is a horizontal line? So we have a horizontal line, line B. What is its slope? Again, we have 2 points. To move from point X to Y, I moved a certain positive distance horizontally, but I have moved no distance at all vertically. So the vertical distance is 0. So the slope is 0 over some positive number, which is 0. 0 divided by anything positive or negative is 0. So the slope of a horizontal line turns out to be 0. The slope of every horizontal line will be 0. What it says is it's not inclined at all to the x-axis. It's in fact parallel to the x-axis. So in particular, the slope of the x-axis is also 0. the equation of a line. So we saw the equation of two very interesting lines, the horizontal lines and the vertical lines. Now let's derive the equation of a general line. So let's say I have some line and I have 2 points on it. So let's take the points as 6, 2, and say 10, 4. These are my 2 points A and B. And I need to derive an equation of the line. What do we mean by equation of a line? Well, this line has been shown graphically. It's a geometric shape. By the equation of a line, I mean a relationship between x and y coordinates. And this relationship should be such that only the points on the line satisfy this equation. And no other point on the graph should satisfy this equation. This equation should capture only the points on the line. So what's the first thing I do when I see a line? Well, I know only one thing about a line so far. I know its slope. So I'll calculate the slope. So the slope is rise over run, which in this case is, the rise is 4 minus 2. I've gone up a distance of 2. And the run is 10 minus 6. I've gone across a distance of 10 minus 6, which is 2 over 4, which is half. So I know my slope is half. What do I do with this? Let me illustrate how I got the slope. This is 4, this is 2. And the slope is the ratio of the vertical rise over the horizontal run. Now to find the equation, let me take a third point on the line. Let's call it C. And let's give it coordinates x and y. It could be any point on the line, so I call it x comma y. And I'll calculate the slope using x comma y. To make life easier, let me take C here, so that I can use rise and run again. So here's C, x comma y, and I'll calculate the slope using B and C. So what's the run from B to C? The run from B to C is x minus 10. What's the rise from B to C? The rise from B to C is y minus 4. So what's the slope of BC, which is effectively the slope of the line? So the slope using the points BC is the run, which is y minus 4 which is the rise y minus 4 upon the run x minus 10. So I have two expressions for the slope, one involving x and y and one which I calculated earlier, which was half. Since this is the same line and the slope doesn't change across points, these two slopes are equal. So I can equate the slopes. So I get y minus 4 over x minus 10 is equal to half. And that's my equation. The equation of the line is nothing more than equating two expressions for slope, since slope totally captures a line. But the right hand side, I've actually used 2 points with coordinates, so I've got a value for the slope, in this case half. And the left hand side, I've used a generic point x comma y on the line and any one of the other points and calculated the slope with these 2 points. So I'll get a y minus 4 over x minus 10 and I equate these two slopes and that is the equation of the line. Let's write it again. Y minus 4 over x minus 10 is half. In general, it would be y minus some point equal to slope. That would be the equation. This slope would be calculated using 2 points and this x, y and a point. Okay, the problem is you've never seen the equation in this form. So all we have to do is play around with it algebraically and all the other forms of the equation will come through. Well, the easiest thing to do is to take the x minus 10 across. So I'll do y minus 4 is half into x minus 10. Now this is called the slope point form of the equation. The name isn't important at all. It's just that it involves a slope and it's one of the points 10, 4. We use the slope m equal to half and the point 10, 4 to get this equation. Were I to open out this equation further, I'll get y minus 4 is equal to half x minus 5. I've distributed the half across the x minus 10. And were I to isolate y, I would get y equal to half x minus 5 plus 4, which is y equal to half x minus 1. So here's another form of the equation. It's the same equation each time, but now I've isolated y. I've written it as y equal to something and something. Well, the first something is easy. That's half x. So it's y equal to mx, where m is the slope, and there's some constant floating around. So in this form of the equation, when I write it as y equal to something, that's usually called y equal to mx plus c, that constant is called c. The coefficient of x is always the slope, because it's the coefficient here. And this constant needs some explaining, so we'll interpret what this constant is later. Intercepts of a line. What does that mean? So here's a line. So there are two important points of this line. Those are the points where the line hits the y-axis and the x-axis. So here's where it's hitting the y-axis, and here's where it's hitting the x-axis. So this is called the y-intercept for obvious reasons, and this is called the x-intercept. And these 2 points are sort of special because this point is on the y-axis, so its x-coordinate will be 0. And this point is on the x-axis, so its y-coordinate will be 0. So for instance, this line will have y-intercept say 3 and x-intercept say minus 4. So another way to describe a line, instead of giving 2 points, can be to say it has a y-intercept of 3 and an x-intercept of minus 4. It's obvious that what we mean is that it has the 2 points 0, 3 and minus 4, 0. Give me an example of a line that does not have a y-intercept. That means it never hits the y-axis. So it must be parallel to the y-axis. So any vertical line will not have a y-intercept. All these vertical lines are parallel to the y-axis. Similarly, give me a point that does not have an x-intercept. Any line parallel to the x-axis. All horizontal lines will not have an x-intercept. By all horizontal lines, I mean all except the x-axis, of course. So if I were to say, give me the equation of a line with y-intercept 3 and no x-intercept, then since it doesn't have an x-intercept, I know it's a horizontal line, and it has a y-intercept of 3. So I know it's a horizontal line going through the point 0, 3. So its equation would be y equal to 3. Find the slope and x and y intercepts of the line 3x plus 2y equal to minus 12. So let's find the x and y intercepts first. What do I know about the x-intercept? It's the point where it hits the x-axis. So what do I know about the point already? I know that its y-coordinate is 0. So I'm looking for the x-intercept. Let me call it a. It's the point a, 0. And since this is the equation of the line, a, 0 must satisfy the equation. So I can plug it in. So I'll put in a for x and 0 for y into the equation. So I get 3a is equal to minus 12, a is equal to minus 4. So I found that the x-intercept is minus 4. How about the y-intercept? The y-intercept is the point where the line hits the y-axis. So its x-coordinate is 0. So let's call the y-intercept 0, b. And I can plug this into the equation. So I'll get 3 into 0 plus 2 into b is equal to minus 12. That's 2b equal to minus 12, b equal to minus 6. So the y-intercept is minus 6. Let's see what the line looks like. It has an x-intercept of minus 4 and a y-intercept of minus 6. So it's this line. This is the line. What's the last thing they want? Rather the first thing, find the slope. Well, now that I have these 2 points, it's trivial to find the slope. I use the 2 points to find the slope. How about if I want to find the slope directly from the equation? So let's go 3x plus 2y equal to minus 12. I'll try to make y the subject of the formula. So I get 2y is equal to minus 3x minus 12. Dividing by 2, I get y is equal to minus 3 by 2x minus 6. Recall that when I write the equation in the form y equal to mx plus c, then that m, which is the coefficient of x, is the slope. So here's the slope, minus 3 by 2. You can always verify by calculating the slope using these 2 points. And what's the minus 6 here? That's the constant plus c. So here c is equal to minus 6. And that's turning out to be the y-intercept. That's interesting. Let's see if that's always true. So, okay, we've completed this question. So, what I'm driving at is, suppose I were to write the equation in the form y equal to mx plus c, then I know that m is the slope. And I need an interpretation for the c. What is the c? For example, this question gave me y equal to minus 3 by 2x minus 6. And the slope turned out to be minus 3 by 2. And I need to know what is the minus 6. So the easiest way to find that out is to put x equal to 0. I'm taking x equal to 0. If I take x equal to 0 in this equation, I get y is equal to m into 0 plus c. So I get y equal to c. So what's it saying? It's saying when x is 0, y is c. That means the point 0c is on the line. And what is the point 0c? Well, the point 0c is the y-intercept. This is the point on the y-axis with y-coordinate c. So in this case, it was minus 6. So my c minus 6, this turns out to be c. It's the y-intercept of the line. So in a general form of the equation y equal to mx plus c, the m is the slope and the c is the y-intercept. The way to prove it is take x equal to 0 and you'll get y equal to c. So the point is 0c, which means it's the y-intercept. Find the slope equation and x and y coordinates of the line graph below. So they want the x and y intercepts. That's very easy. I'll just read it out. The x-intercept is 6, 0. The y-intercept is 0, minus 6. What's the slope? I just use these 2 points to find the slope. So my 2 points are 6, 0 and 0, minus 6. So to go from A to B, I went down a vertical distance of 6. So the rise is minus 6. And I went across a horizontal distance of minus 6. So the run is also minus 6. So the slope is minus 6 over minus 6, which is 1. Now I need to find the equation. So I have the slope and I have the x and y intercepts. What's the quickest way to write an equation if I have the slope and intercepts? It's y equal to mx plus c, where this is the slope and this is the y-intercept. So I get the equation is y equal to 1 into x minus 6. C is minus 6. Which is y is equal to x minus 6. That's the quickest way to write the equation. If I didn't have this y-intercept, then I'd have to equate two slopes. I'd have to equate the slope of one with a generic slope, which I calculate using a point xy and another point. Identify the equation of the line shown below. So they've given us a graph of the line. So let's first quickly figure out the intercepts, because those are always useful. So the y-intercept is 2 and the x-intercept is minus 3. Now, since they want the equation and I already have the y-intercept, all I need is the slope, and I have these 2 points to get the slope. So the slope, which is rise over run, let's calculate both. So I'll move from the x-intercept to the y-intercept. I have a horizontal distance of 3 and a vertical distance of 2. So that's rise over run is 2 over 3. And I'm done. My equation will be y equal to mx plus c, which is y equal to 2/3 x plus 2. The y-intercept is c. So that's my equation. Well, the way they've given it, nothing tallies. So I've got to play around with my equation to make it match one of them. So I multiply throughout by 3. So I get 3y is equal to 2x plus 6. I multiplied both sides by 3. How does it match? Yeah, it's B. 3y minus 2x is equal to 6. So B is the answer. A line passes through 4, minus 9 and has a y-intercept of 2. I'll leave this to you. The 2 points given are 4, minus 9 and 0, 2. A line has x and y-intercepts 1 and 3. So x-intercept is 1, that means the point 1, 0. Y-intercept is 3, it means the point 0, 3. Once you have the points, finding the equation is easy. The table shows the temperature of a pool at various times after the heater is turned on. So we have the time after which the heater is turned on and the temperature which seems to be rising, 56, 62, 66, 74. Plot the points on a graph. So I'll take the x coordinate as time and the y coordinate as temperature. So this is time in hours and this is temperature T. So time 0, let's say this is 56. At time 3, it's 62. At time 5, it's 66. And at time 9, it's 74. So this is my line. 3, 5 and 9. 56, 62, 66 and 74. So I plotted the 4 points using time as the x coordinate and temperature as the y coordinate. Express the temperature of water as a function of time. That means find the equation of the line. If I found the equation of the line, I'd get y in terms of x. That means I'd get temperature in terms of time. And that's easy to do because they've given me 4 points. So I take any 2 points and I find the equation. Let's take the first 2 points. So the first point is 0, 56 and the second is 3, 62. So what's the slope? Well, the slope is easy. It's 62 minus 56 over 3 minus 0. That's 6 over 3, that's 2. So the slope is 2. What's the y-intercept? Well, that's 56. This is where it hits the y-axis. So the equation is y equal to 2x plus 56. Or, in terms of time and temperature, T is equal to 2h plus 56. That's the equation. Find the temperature of the water after 15 hours. So I have my equation. T is equal to 2h plus 56. They want the temperature after 15 hours. So h is 15. So when h is 15, they want to know what's T. So plug in 15 for h. That's 30 plus 56. That's 86 degrees Fahrenheit. So the temperature after 15 hours will be 86 degrees Fahrenheit.